Hello and welcome to lesson number 8 of Unit 2B, Quadratic Functions, Forms, and Transformations in our grade 11 University College math class. This is converting from standard form to vertex form. So this unit, or this portion of Unit 2 is forms, so we're going to be concentrating on the three forms of the quadratic that we were introduced to or reintroduced to in the last lesson, which is vertex form, factored form, and standard form. So today's lesson we're going to learn how to go from standard form, which as I said in the last lesson is kind of the most useless form, into vertex form, which is maybe the most useful form. So how do we do that? There's a couple of different ways. One way is a procedure called completing the square, and that's what we're going to spend the bulk of the lesson looking at today. I'll also show you how to use the what I called in the last lesson, I believe, is like the cheat method of just getting to the vertex really quickly using a formula and then just substituting that into the basic equation. So let's just jump right in. Completing the square, as I've already said, is a procedure for changing from standard form into vertex form. In order to do that, we need to recall what a perfect square trinomial is, which we did back in Unit 0. And a perfect square trinomial looks like this, where you have a trinomial kind of set up, which when factored gives you a single binomial squared, or a similar second version here, where you have an identical binomial squared. The difference, of course, being that if we have a positive 2ab here, we're going to have a positive inside the bracket, and a negative 2ab here results in a negative in the bracket. So recalling how to do this, or that such a thing exists, is at the heart of completing the square, since completing the square is sort of shorthand for creating a perfect square trinomial in the absence of one. So let's just jump right in. If we're talking about factoring the following, I've already got this one written out, but we would want to find the thing that multiplies to 36 and that adds to 12. That happens to be 6 and 6, which we put into the brackets. And noticing that those two numbers are identical, we can then write it as a single binomial all squared. Let's do something similar with example B. We're going to try to factor this. So we're looking for the two numbers that multiply to a positive 9, but that add to a negative 6. So those two numbers will be negative 3 and negative 3. We'll pop those into the brackets, x minus 3, x minus 3. And as you can see with two identical binomials, we can write that as x minus 3 binomial squared. So what are we noticing here? If we were starting, say, from a point like this and trying to work our way backwards, well, we know that this value inside this bracket needs to multiply together to give you the c value, but add together to give you the b value. So if we were going to try to create some perfect square trinomials, that's sort of the next step that we're going to look at. Imagine here that you were given x squared plus 16x plus something, and we're trying to make a perfect square trinomial. How do we go about doing that? Normally in class we'd spend some time trying to figure it out and discuss it. I'm just going to give it to you straight up here. You're going to take that b value, which in this case is plus 16. We're going to cut it in half, which is dividing it by 2, and that's going to give us plus 8. And that value we square to find out which c value will create right here a perfect square trinomial. Since if we were to factor this, it would give us something that multiplies to plus 64 and adds to plus 16. That would be x plus 8 and x plus 8, which would give us x, kind of ran out of room there, x plus 8 all squared. And as you recall, vertex form of a parabola is y equals a x minus h all squared plus k. What you're going to notice, hopefully, is that this thing that we've just created shows up at the heart of vertex form. So that's our goal. That's why we're creating a perfect square, is so that we can transition from a standard form into a vertex form and get this really challenging piece sort of in place. Let's continue with this exercise number 2 with B. So if we wanted to create a perfect square trinomial here, as I said, we're going to take our b value, and that's going to equal, so c then would equal negative 10 divided by 2, and we're going to square that. That's going to give us negative 5 squared, which is going to give us 25 as the value we put in to create our perfect square trinomial. Again, if we were to factor this, you would end up with x minus 5 and x minus 5, which we would then rewrite as x minus 5 all squared. Again, a piece that looks perfectly at home in the middle of vertex form. And again, I want to point out that this value that we've cut in half here, negative 5, the value we arrive at when we cut our b value in half, is the same one that populates our two binomials or single binomial squared in the bracket. Okay, let's try one more. We have x squared plus x plus unknown value. So we are going to find our c value by taking the b value, which is 1, dividing it by 2, and squaring it. So 1 divided by 2 is a half, so let's just leave it as a fraction, I guess. And then when we square it, we're going to have 1 squared over 2 squared, which is 1/4. So we would then have in our brackets, it was x's, so we'd have x. So I guess we'll put the quarter up here. And then we would have x, because this is a positive value here, this will be x plus a half and x minus a half, or x plus a half and x plus a half, which would give us x plus 1/2 all squared as the heart of our new perfect square trinomial. Okay, so we have a bit of a procedure now to go through. It includes the thing we just did, which is creating a perfect square. I'm just going to work through one. There's a whole bunch of instructions here written on the right side. I'm just going to walk you through one, and then we can refer to those as we need to. So here we have y equals x squared plus 6x plus 7. So this is standard form. We know this because there's no brackets. If we want to transition this into vertex form, we need to complete the square. And we start that by creating a perfect square trinomial. Now, we're going to add a value there. After the 6x, that's going to make this piece here a perfect square trinomial. However, you can't just go willy-nilly adding something to an equation. It has to have the same thing done on both the left and the right sides. So one way to counteract adding something is to subtract something. So we're going to do that. Now we're going to subtract it right away. Again, that seems a bit redundant, but remember, we're doing this to keep our equation balanced. And then there is that plus 7. So from the original equation, all we've done really is add this little piece right here. We're adding that perfect square value, like adding the value that will create a perfect square, and then we're subtracting it right away to keep the equation balanced. You're going to see how that plays out in about a second here. So how do we figure out what the value is that creates the perfect square? Well, let's just scooch out. So we're going to take our b value, which is 6, and we're going to divide it by 2. And we're going to square it. So dividing 6 by 2 gives you 3, which we then square to give us 9. And one of the things you'll notice about this completing the square procedure is that this value is always going to be positive, because whether you square two negative numbers or two positive numbers, you're always going to end up with a positive result. So here we're going to add that 9. Whoops, that's a highlighter. We're going to add that 9, and then to keep the equation balanced, we're going to subtract that 9. So there we go. Next thing we want to do is we've got here, as I said before, our perfect square trinomial that we've just created, and we're going to factor that. So we're going to factor that. We're looking for the two things that multiply to plus 9 but add to plus 6. As I said, it's actually going to be this value here inside the bracket, plus 3. But if you want to just figure it out old school style, you can do what I just said in verbally, which is what multiplies to plus 9 but adds to plus 6. So that's going to be 3. So that's going to be x plus 3 all squared. So I've just factored that and written it as a binomial all in one step. Actually, let's spread it out a bit for this one anyway. So this bit here, this is the first 3 terms being factored. Now we have these other two values just kind of sticking around on the outside. We have this minus 9, oh come on highlighter, we have this minus 9 and we have this plus 7. And that just needs to be simplified. So a minus 9 and a plus 7 gives us minus 2. So from here, we're now going to rewrite those two binomials that are identical as a single binomial squared, plus 3, all squared, and there's our minus 2. So we have transitioned from standard form to vertex form. The vertex now, of course, will be, looks like a positive 3 is a negative 3, and we take the 2 at face value. Our a value is 1, so our direction of opening is up with a plot pattern of 1, 4, and 9 from our vertex. So there you go, that's completing the square. The instructions on the right just sort of verify the thinking at every step. Hopefully that makes sense. You can feel free to re-watch if you'd like. But again, at the heart of this, we're creating a perfect square trinomial inside the standard form equation, because once we factor it, we end up with this handsome little piece right here that is at the heart of vertex form. And from there, we just, by balancing the equation, we then end up with the k value. So there is completing the square. In the second part of this video, we're going to look at a couple examples, and then if there's time, talk about the cheat method. So we'll see you in part 2.